and welcome to Programming C course. In lesson number 2, we are going to cover features of C language, C character set, keywords, identifiers, data types, constants, and variables. These are building blocks of a C program. Now, let me tell you first about some features of C programming language. C language is a procedural language, meaning when we write C programs, we write instructions step by step, and when it is executed, those instructions are executed step by step. That's why it is called a procedural language. Secondly, C language is a modular language. C language has a very rich libraries of built-in functions. We can use those built-in functions when we write our C program. That keeps our C program brief and nice. That's why it is called a modular language. The strength of C language comes from its built-in library functions. Thirdly, C has a rich set of built-in operators. We will be studying different types of operators: arithmetic operators, logical operators, relational operators, bitwise operators, and so on. Fourth, C is a general purpose language, meaning C is used everywhere from writing an operating system to writing any application software like games or photo editing software. Next, C is statically typed, meaning when we use variables in C program, before using those variables, we have to declare those variables at the start of the program, giving it a data type. Otherwise, we can't use those variables inside the program. That's why it is called statically typed. C is fast and efficient. C program is easy to extend. C language is machine independent or highly portable. Highly portable means the C program written in one machine can be transferred to another machine, even though those two machines have different architectures or manufacturers. Now, C language has the combined form of an assembly and high-level language. It has the capabilities of an assembly language, and C language is very close to human language, so it has features of high-level language. So since it has both the features of an assembly language and high-level language, sometimes it is called a middle-level language. C is also a structured language, meaning when we write C program, the instructions in the program are written structurally, module by module. Now, C is a case-sensitive language, meaning uppercase letters and lowercase letters are treated differently. And lastly, C language was developed by Dennis Ritchie at Bell Laboratories in 1972. Now let's start with C character set, which is building block of various program elements such as constants, variables, operators, and expressions. Now when we try to write constants, variables, and expressions, we will be using different characters. Those characters can be categorized into 4 groups. The first one is letters, uppercase letters A to Z, and lowercase letters from A to Z. Digits we will be using from 0 to 9. These are the decimal digits. There are lots of special characters or special symbols on our keyboard. We will be using almost all of them except 2. Now, fourth is escape sequences. These escape sequences represent special symbols, or they are control characters to format the output. Even though they consist of 2 or more characters, escape sequences are treated as single character. For example, \n means new line character, \0 means null character. All these represent only one character. I will tell you about this later in detail. Remember, 2 special characters @ and backtick, which is in your keyboard, are not used in C. Now, let's see what are those special characters used in building our program elements. Here is a list of all the special characters: comma, period, semicolon, colon, question mark, exclamation mark, apostrophe, quotation mark, vertical bar, slash, backslash, tilde, underscore, dollar sign, Persian or modulo sign, blank space, ampersand, caret, asterisk, minus sign, plus sign, equal to sign, less than sign, greater than sign, left parenthesis, left bracket, right bracket, left right brace, number or hash sign. These are special characters we use in C language. Next, escape sequence. An escape sequence is a sequence of characters starting with a backslash that represents a special character or non-printable control character used for formatting the output on our monitor. Some escape sequences are not printed. For example, \n, new line, is not visible on the monitor. It is used for controlling the format of what we are printing on the monitor. \t, horizontal tab, is also not seen on the monitor. It is used to control the formatting of what we're printing on the monitor. \0, which is known as null character, it is used at the end of a string. I'll tell you about this more in the later slides. If I want to print a single quote on the monitor, then I cannot use single quote by itself because single quote has a special meaning in C language. It is used for specifying character constants. Similarly, double quote has a special meaning in C language. It is used for specifying string constants. So if we want to print single quote or double quote, it cannot be used by itself. We have to use a backslash. Otherwise, it would be confused with our special meaning of a character constant or a string constant. That's why we have to use along with a backslash. Now, every C word that we will be using in writing our C program is classified as either a keyword or an identifier. First, we will do keyword. Keywords are certain reserved words that have standard predefined fixed meaning in C. These cannot be used for naming any kind of identifier because keywords can be used only for their intended purpose. Keywords are the building blocks for program statements. All keywords must be written in lowercase. Remember this. Keywords cannot be written in uppercase. It is possible to use an uppercase keyword as an identifier. However, it is considered a poor programming practice, meaning the names of keywords that we are having in C language can be used as an identifier in uppercase, not in lowercase, but it is not a good programming practice because you will be confused whether it is a keyword or identifier. So we should avoid using the names of the keywords as an identifier. We will learn about identifier in the coming slides. So briefly, I will introduce you what is an identifier in this slide. On the right side, there is a diagram. Identifier means any kind of variable, any kind of array, any kind of function for which you can give names of your own choice. That's why these identifiers are user-defined functions or variables or arrays, whereas keywords are reserved words defined by the C language. You cannot change the meaning of these keywords. Identifiers, you can change its name because its name is given by you only. We have 32 keywords in C language. The first one is char. It's a short form of character. It is used to define a character data type. Second one is int, integer. It is used to define an integer data type. The third one is float. It is used to define a real numbers having decimal point. Double is also used for defining a real numbers, but it will have more digits after the decimal point. And next is void. It is also used to define a data type, but this void doesn't have any data type because void means nil. So the first 5 keywords are used to define data types. We will learn more about this in the coming slides. The next group, short, long, unsigned, and signed, are data type qualifiers. They qualify the data types that we declare using char, in, float, double, further. Next group is while, do, and for. These are keywords used while we write loop in C program. The next group is if, else, switch, case, default, break. These are used when branching in our C language. And the next group is continue and go to along with break. These are used in jumping in our loop, jumping from one part of a program to another part of the program. The next one is return. It is used to return values from a function to the main function or the calling function. The next one is size of. It is used to find out the size of a variable or a data type stored in the memory. The next group is enum and typedef. Typedef means type definition. These two are used to define data types by the user. The next group is struct and union. These are more complex data types defined by the user. The next group is auto, register, static, and extern. These are storage class defining keywords. And the last group is constant and volatile. These are again qualifiers of our variables, whether the variable is going to be constant or whether the variable is going to be kept as volatile, changeable. Now let's come to identifiers. Identifiers are names that are given to various program elements such as variables, arrays, and functions. These are user-defined names and may consist of letters and digits with a letter as a first character. Remember, the first character should be a letter, not digits. Both upper and lowercase letters are permitted, although lowercase letters are commonly used and preferred. Upper and lowercase letters are not interchangeable because they are treated differently. The underscore character can also be included in identifiers and is considered to be a letter. An underscore is often used in the middle of an identifier as link between two words. As you can see on the right hand side, I have used an underscore between my and var, my variable, as a link between the two words my and var, and in someone also as a link between some and one. An identifier may also begin with an underscore, though this is rarely done in practice and it is not advisable. As you can see from the right side of this slide, these are the ways in which we can give the names of an variable. We can use both letters and numbers like y1. We can use both uppercase and the lowercase like lowercase total and uppercase total. Lowercase total and uppercase total are treated differently. They are two different variables. They are not same. So uppercase letters and lowercase letters cannot be used interchangeably. In the names of the variables, we can use underscore in between words, preferably not at the start of the variable. Now, keeping this in mind, let's go to rules for naming an identifier. First character must be an alphabet. It must consist of letters, digits, or underscore. No special characters are allowed. On the right-hand side, you see red at the red to variable declared. You cannot name a variable like this because the name of a variable cannot contain a special character. This is illegal. The name of a variable cannot contain white space also. That's why on the right side, the variable my address having a white space in between is an illegal declaration. It is not allowed. A keyword cannot be used as an identifier. On the right side, you see a variable char. Char is already a keyword which have a fixed meaning. So the same word char cannot be used as the name of an identifier. Only first 31 characters are significant. When you give the name of a variable, try to give it a very short and brief name because the rest of the characters after 31 characters are not significant. Now let's come to data types. C language is rich in data types. ANSI C supports three classes of data types. The first group is primary data types. The second group is derived data types. The third group is user-defined data types. Within the primary data types, we have char for character constants, int for integer constants, float for real numbers having decimal points, double for longer real numbers, and void is just nil, which doesn't have any data type. In derived data types, we have arrays, functions, pointers, structures, then unit. We will do this in the later lessons. And the next is under user-defined data types, we have enum and typedef. Enum means enumerated, listed, 1, 2, 3, 4, 5 listed data types. And typedef means user-defined data types. We have already 5 data types: char, int, float, double, and void. Using these data types, you can define other data types by using typedef. Typedef means type definition. Before we proceed with primary data types in detail, let me first explain to you about bits and bytes. A bit is the smallest unit of data that can be stored by the computer. Each bit is either 1 or 0. A byte contains 8 bits. Every character or symbol in your keyboard is encoded with 8 bits or 1 byte. Besides bits and bytes, there are units of storage such as nimble. 1 nimble is equal to 4 bits. 1 kilobyte is equal to 1024 bytes. What is the reason for using 1024 instead of 1000? Because in binary we use powers of 2 instead of powers of 10. 2 to the power 10 is 1024. That's why 1 kilobyte is equal to 1024 bytes. Similarly, 1 megabyte is equal to 1024 kilobytes. 1 gigabyte is equal to 1024 megabytes. And lastly, 1 terabyte is equal to 1024 gigabyte. Now that we have learned units of storage, we can now proceed with primary data types in detail. Now let's come to primary data types and see in detail what are these. The first one, char, represents a single character, and the memory requirement in RAM is 1 byte for a char data type. All the characters are stored in char data type, and 8 bits are reserved for storing a char data type. The next one is int, integer. All kinds of integers are stored in int data type. It has a memory allocation of 2 bytes. 1 byte is equal to 8 bits. So 2 bytes will be equal to 16 bits. 16 bits are allocated for storing an int data type. For float, which is real number having decimal point or an exponent, the memory requirement is 4 bytes, that is 32 bits. For double data types, that is long real numbers, which is known as double precision floating point number, the memory requirement is 8 bytes, that is 64 bits. And lastly, void data type, it has no values. We have 5 basic data types: char, int, float, and double. We can ignore void because it doesn't have any data size. We can shorten these data types or lengthen these data types using data type qualifiers such as short to shorten, long to lengthen, unsigned to make it positive, only positive. Now, I have given a list of the data types along with their data type qualifier. Let's see one by one. Char, it occupies 1 byte, as I already told you. Now, 1 byte has 8 bits. Out of those 8 bits, 1 bit will be using to signify whether it's a negative number or a positive number. So 1 bit is reserved for sign. The remaining 7 bits will be used for storing the number. So what are the total possibilities of numbers that can be stored in a 7-bit combination? That will be given by 2 to the power 7, because each slot has 2 options. The first slot has 2 options, 1 and 0. The second slot has 2 options, 1 and 0. So we have 7 slots for storing number. So 2 to the power 7 is the total number of options that we can use for storing a number in the 7-bit combination. So 2 to the power 7 is 128. Since we have reserved 1 bit for plus or minus, so we can store 128 negative numbers on one side and 128 positive numbers on the other side. But what you have to remember here is we have to store the number 0 also. So from the positive side, out of the 128, 1 is 0. So the largest positive number that can be stored in 1 byte will be 127. 1 less than 128. In negative numbers, we can store from -1 to -128. Similarly, int has 2 bytes in size, so it has 16 bits. So the total possibilities will be, if it is unsigned int, it will be 2 to the power 16. So 2 to the power 16 is 65,536. Since 0 is included in the positive number, so we have to subtract 1 from the largest number. It will be 65,535. So in an unsigned integer, that is only if we make int data type only positive numbers, then we can store from 0 to 65,535. Now, if int data type is not unsigned, if it is signed integer, then half of those numbers will be negative numbers. So how will we determine the maximum number or the minimum number? We have 2 bytes, that means 16 bits. 1 bit will be reserved for positive or negative sign. So we have 15 bits. So 2 to the power 15 is 32,768. So there will be that much positive number and that much negative number on the other side. But in the positive side will be 1 less because 0 is to be included in the positive side. So we have from minus 32,768 to positive 32,767. Now, an int data type can be shortened or lengthened using the data type qualifiers. For example, if I use short int, then it will be shortened, but it depends upon from compiler to compiler. For the compiler that we are using, even though we use short before int, the int data type is not shortened, it remains 2 bytes. But if we use long before int, then the data size is increased to 4 bytes from 2 bytes. So long is used to lengthen the int data type. Now similarly, the float data type can be lengthened by using the long data type qualifier. Float usually has a memory requirement of 4 bytes. If we use long, then it is increased to 8 bytes. Now double has memory requirements of 8 bytes. If we use long before double, then it is increased to 10 bytes. That's how we can modify the given data size of int, float, and double. Now let's come to signed and unsigned. If we use signed before a data type, then it will be a signed integer, meaning it can have both negative numbers and positive numbers. If it is unsigned, then it is going to be only positive numbers. For example, if we use the unsigned data type qualifier before char, then we cannot represent negative numbers. So the number of positive numbers we can represent with this 1 byte will be increased to 255. Similarly, we have int data type of 2 bytes. Its values ranges from minus 32,768 to plus 32,767. Now, if we use the data type qualifier unsigned, then the values that can be stored in that 2 byte will be from 0 to 65,535, all positive numbers. So maximum number that can be stored in 2 byte is increased to 65,535. So these are the different ranges of the values that can be stored in these data types. Here, what we have seen is the basic data types can be modified by using the keywords short, long, and unsigned. Remember, these are called data type qualifiers. They modify the data size of the basic data types. Now, lastly, one thing I want to tell you is that if these data type qualifiers, short, long, and unsigned, are used without any basic data types, then the C language or the compiler will treat the data type to be int by default. Once again, I'm repeating, if short, long, and unsigned are used alone without any basic data type, then the C compiler will treat it to be by default an int data type. That's all for now. Thank you, everyone.